So, welcome to a fine afternoon here at RVAsec in May 31st, 2013. If this were 1984, George Orwell might be telling us that war is peace, freedom is slavery, ignorance is strength, JavaScript is harmless. If it were 1996, we might be worried about Java vulnerabilities and browsers worrying about how to secure Java inside them. Or that could also be 2013, I suppose. Might have little things change. If this were also 1996, we could possibly be reading Frac 49 or looking at some of the insecure.org mailing lists about things like cross-site scripting and SQL injection and command injection before they were called cross-site scripting, SQL injection, command injection. So one of the things I want to try and do here is have a little bit of sense of history, but as well try and figure out what concepts we want to make sure that we're bringing in and building from a design perspective to improve security versus the same problems that we keep implementing over and over and over again because we're implementing the same based on the same insecure foundations. And one of those foundations is JavaScript. And so that's what I want to focus on today. And this is a little bit less about JavaScript itself and more about how to corral it and make it safe inside the browser. So there's a lot of aspects and a lot of mistakes you can make within JavaScript, but many of them actually fall more on the performance and optimization level as opposed to a security level. So let's talk about HTML5 and kind of have an idea how HTML5 can give us more confidence that we're building web applications where we have to worry less and be less concerned about what is going on inside that JavaScript bundle or that JavaScript code. And if we're browser vendors, of course we still have to be really worried about JavaScript. Because if we look at the JS Fun Fuzz, created back in late 2007 or 2006 by a fellow named Jesse Ruderman. And in those 7 years, it's basically a JavaScript program that internally fuzzes JavaScript, the spider monkey for Mozilla. And in this time, it's actually gotten almost 2,000 bugs created. And not necessarily all of them are security related, but my point here is that JavaScript is a really, in a way, a very frail, tough framework to keep secure. And if we think about pwn-to-own contests and a recent IE exploit from end of 2012, these exploits are hard to find, but in order to exploit them, it only took, in that case, about 12 lines of HTML. So we can move beyond buffer overflows and heap and smashing the stack for fun and profit and do what I prefer is like lazier things and just write some JavaScript, and it's a lot easier. So as I mentioned, there are a lot of traps that you can fall into dealing with JavaScript. Some of them, or a lot of them, are around the use of how you're declaring variables. Are you just declaring them naked, or do you declare them with var? What about having a block, or what's the scope of them? And we can actually kind of think of this as the same concept of PHP. PHP has a lot of old vulnerabilities related to superglobals or uninitialized variables. We can apply these same kinds of concepts to JavaScript, even in the sense of interesting quirks in the language that new developers might get tripped up on. Things like the type of null is actually an object. The type of an undefined is an undefined. A null can be equal to undefined, but it's not strictly equal to undefined. And I just highlight this as one of the things that can be a little bit of a confusion or a source of error in certain types of programming. So on that one hand, developers can find this language confusing. On the other hand, hackers can find this language almost self-obfuscating and pretty awesome from a sense of a hacking perspective. If you can see the bottom of the slide from the back, it's basically an alert pop-up. But it's the word alert that's been created by taking advantage of the negation of an object that's been cast to a string, that's been cast to another object, that's doing an index onto a single character, that's using string concatenation. And all this is pure JavaScript, perfectly valid JavaScript. So if you're relying on regular expressions and pattern matching to block those alert pop-ups, that's probably already mistake number one, because JavaScript is so weird, or so flexible from that perspective, that there's a lot of ways to bypass those types of security. I do want to take a slight tangent. Since we're talking about JavaScript and how to use it, it gets used a lot to build these HTML5 apps, to build these really awesome apps that are basically like desktops. Look up the Mozilla's Banana Bread demo. It's basically a first-person shooter purely within the web browser. It's really awesome. But we also want to be careful about using crypto or using JavaScript properly. For example, if we want to try and use channel security, we want to use encrypted communications, JavaScript is the wrong place to do it for many, many reasons. First of all, it's already been, well, solved to a degree, if we want to call it solved, using SSL and TLS. Better yet, we should be relying on something like HSTS and DNSSEC, because those are much more powerful, setting up the end-to-end channel security, identity, and what have you. Some other catches there could be around crypto is that a lot of crypto relies on good, cryptographically strong, there's your hint right there, random number generators, of which it's not really clear that the browser is a good way to generate these or is a good way to have them yet. I will point out the Stanford JavaScript Crypto library, a very excellent effort that has built in not only a random generator that has very good cryptographic properties for it, but as well as it's implemented things like AES, it's implemented some public key, private key type of encryption, so you can actually have encryption primitives within the browser itself, which we do have to be a little bit careful about how much we want to trust that browser, because again, it's a prototype style language, you can actually override a lot of things, you don't have a pure trusted environment, but if we do have at least a degree of trust, or we want to apply some security engineering, what we can start to do is try to encourage developers to minimize this lifetime of the plain text password. For example, we all know, or we all should know, that that password should be salted and hashed. Ideally, we would be following something like the PBK-DF2 algorithm to also make this a hashing algorithm that requires a big work factor, that requires a lot of effort on the part of the attacker to get to. And if we start to hash this in the browser and then just send that final hashed version and store that on our database, then when the server's finally exposed by SQL injection or what have you, there's less of a chance of these plain text or these poorly protected passwords being divulged. We can also do things like just a client challenge response between the browser and the server. And again, this is just shifting where we're handling security. So it's not necessarily better or worse in any way, but I would encourage it in the sense of the lifetime of the password as plain text lives as short as possible within the browser, and then once it goes onto the wire, you're dealing with a hashed version. So let's move from the past, coming out of the Netscapes and Shockwaves of 1996, and we have this beautiful doc-type HTML. That's basically all you need to have HTML5. So along the way, there's actually some really good things that happen. On the one hand, we have a lot of stuff that's kind of out of our domain unless we're browser developers or browser vendors. Process separation, sandboxing, some very weak and meager XSS protections. But probably the best aspect of the race for all these browsers to adopt HTML5 is that they've had iteration after iteration after iteration, and they've all tried to make auto-updating as easy as possible so that the users have the latest and greatest. And it's not so much of a security concern, even though it helps with security. It's more a push, so now that, oh, hey, we support WebSockets, we support WebGL, or we actually have to take WebGL out, and I'll talk about that in a second, and put WebGL back in. Or we have Web Storage API and all these different things. So this has actually been a good thing about browser security. And that's independent of HTML5 technology. It's more just a pattern, a byproduct of the race to have new and new featureful browsers. But if we're going to talk about security, of course, we have to talk about cross-site scripting. And this is one of the things that comes up when people say, HTML5 is worse. HTML5 will make us insecure. HTML5 web apps are terrible, or they bring a whole new world of danger. And I'll try to temper that a little bit and bring some more sanity to that discussion. Really, I think when people said XSS is worse, all they really meant was this new autofocus attribute. It meant that now, if you were able to inject cross-site scripting into an input field, rather than having to rely on like an on mouse over or an on click, so your victim had to come and move the mouse over it, you have autofocus that can trigger the on focus box, and automatically it's going to execute. Okay, that's kind of cool, but it really fundamentally boils down to this website has an HTML injection vulnerability into it. Really what the point is that HTML5 has new elements, new attributes, So if you're using those regexes, you had to be really careful to keep up with the canvas element, the audio element, the video element, these types of things. And if you were relying on blacklisting anyway, you're probably failing to prevent one of these payloads. These are just a few of my favorites that are really good against defeating regular expressions and pattern matching, because HTML is a nice parsing language and regexes are poor at parsing. One of the other things that HTML5 does is have client-side, well, I'll call it validation for this point, but it has client-side input types. And these are so that on small devices or web app or on laptops even, you can have different input types. So if you know this is supposed to be a date, you can set up the date picker. If you know this is supposed to be a password or what's new, a number, you'll just have a keyboard that shows numbers rather than the entire keyboard. And my point here is that, hey, this is something new with HTML5, but the developer that relies on client-side validation as a security mechanism is the same developer that existed back in 1996 that didn't realize that the client is not to be trusted. And this is just one of those fundamental security tenets that we repeat over and over and over again, but the mistakes continue to happen. And that's where I think, as I'll highlight in a little bit, we finally, with HTML5, have some ways to design some more security into that web application, and that way those implementation errors become a little less effective or a little less bothersome. So I was talking about cross-site scripting. Here's another one talking about CSRF. So a get-based CSRF, which, for example, has existed since the HTML 1.0 spec. It wasn't new in 2006 or 2005. It was just given a name a few years ago or several years ago. But originally, it could have been done with an image tag. Now, Mozilla, for example, is showing a prefetch attribute that you can add to a link. And what that will do is automatically make that request, just as if, for example, it were an image. And you can use it for CSRF. Now, this isn't a bad thing in terms of HTML5. It's just a new feature that's exploiting an old vulnerability that already existed. One thing that's improving is that, well, in this case, sadly, we don't have the origin header yet, which is a good thing for HTML5. So more foreshadowing for you. We have a refer, but Mozilla did at least add this x-moz prefetch header. So at least we have a header that can distinguish for us that this is a prefetch request. And technically, that request is just made so the application could make decisions based on what it wants to serve, rather than a real security decision. But we're starting to have to rely on headers more and seeing headers as a more helpful security mechanism, because another thing that HTML5 does is make it a little harder in many scenarios to build custom or overwrite, I should say, default headers within requests. So let's talk about some HTML5. So same origin policy. This is the bedrock of web security in the sense of making sure that different domains, different origins don't commingle and interfere with each other. Now, the iframe has always been an excellent client-side mechanism for sandboxing content. However, what developers realized is that iframe was being used as a crutch, and it also made certain things a little bit harder to do. So developers would sometimes then avoid using the iframe. So what they decided to do was add some new attributes, like a seamless and a sandbox. And what this actually is with iframe sandboxes is sort of like a customs inspection. It's looking to see what's in this HTML and do I want to execute it. So we can have a normal JavaScript pop-up if we're loading our infected HTML in an iframe, or we can apply the sandbox attribute and JavaScript is disabled. So we've disabled the exploit. Now we haven't disabled the vulnerability that was present in here before. So again, this is the idea that we're actually designing some security. We have now a security layer on top of our web app. So iframe sandbox is very helpful. And now, of course, we can even actually say the sandbox is allowed to run some JavaScript. But even if we run JavaScript in the sandbox, there's an interesting quirk here, interesting nuance, is that it still won't allow you to access cookies or any of the web storage APIs. So this is pretty interesting too, is that we have sandbox now within only the browser itself, and you can't get access to these cookies or these headers. And cookies, for example, often very sensitive, very security related if we're talking about CSRF or lots of other types of vulns. But of course, we're hackers. We want to see interesting things. We don't just care about developers writing more secure web applications. We want to think creatively. We want to think, how can we abuse this? Well, if you're familiar with clickjacking, there's one technique that web applications use is basically looking at this top.location technique in JavaScript. A little blob of JavaScript they'll use to make sure that this web page hasn't been framed. So it's an anti-framing technique. But let's say now I take this web page that has this JavaScript-based anti-framing technique, and I put that inside an iframe sandbox that disables JavaScript. Voila, I've now bypassed that countermeasure. So again, this more highlights that this JavaScript-based countermeasure to clickjacking was itself kind of weak, and we have something better. We should be using the xframe options deny, because that's a header that can be deployed at the server level. We don't have to rewrite any of our HTML. We don't have to modify any code, and it's a much more robust, much more secure method of protecting the website. So if the iframe sandbox was sort of like the customs inspection, content security policy, you could think of this more like passport control. And once again, we're applying this concept of granular access and least privilege access to the same origin policy. Once again, it's a header only, so we see now this trend to relying on headers to instruct and implement or as a reference for security. And it's really simple, straightforward. You basically say what kind of source attributes can load what type of content. In this case, any default source attribute, like an image or an href, can load content from origins that are from its own domain, in other words, self, or it's kind of like the this operator if you're an object-oriented type of person. But we could also say we're going to do that for everything except frames. And in this case, this infected iframe would be defeated. And what it's doing, once again, is going to block exploits. It's not going to block the vuln. So let's say we have just this default source of self. Content security policy is going to say, I'm not allowed to execute this newfangled HTML5 autofocus cross-site scripting, because this is what's referred to as the inline JavaScript. Of course, we could execute it if we want to do unsafe inline, but once again, we've just actually kind of weakened the intent and purpose of what CSP is. And I point this out because unlike the clickjacking, just being able to throw on an xframes options header, this actually does require modifying code. So here's an example with jQuery and a string concatenation that can be injected with an image source. So there's a DOM-based cross-site scripting here. It's a very simple payload. It's going to pop up an alert. And this is not a vulnerability within jQuery. This is actually a mistake of string concatenation of how the developer is using jQuery. So this isn't like something that should be patched in 1.8.3 or 1.9 or something like that. But to apply content security policy to protect ourselves from this case, we do have to rewrite that page so that we're moving the JavaScript that was in the block down to its own JavaScript. In other words, we have to take it out of inline mode. The same JavaScript remains vulnerable, but if we try to use this attack payload then, a very simple payload, it's no longer going to pop up that alert window. So we've now blocked DOM-based cross-site scripting using content security policy. However, we've done that at the expense of decoupling the HTML and JavaScript. And if you're jQuery hackers, then it's the idea of changing the .attribute function and just start using .bind or .click or .on. And those don't build inline events. And you're probably already using those anyway. So this is the type of thing that additionally jQuery is already being tested and trying to be as content security policy safe as possible. So this also speaks to the idea of reuse code and rely on code that's being developed by experts in a particular domain, such as security or working with CSP or working with performance, rather than trying to build everything from scratch. But of course, since we always want to try and look at this from multiple perspectives, what if we found an HTML injection exploit inside a web application and we added our own content security policy header that said default source, none? Suddenly, we have a really effective denial of service against this site, because what's going to happen is that any browser that loads this HTTP equiv and follows this CSP instruction is not going to load any of the rest of the content. So from the browser's perspective, the site is broken. It doesn't work. And yet it's a denial of service that we don't have to rely on bandwidth. It's a type of DOS that relies on application level or application misuse or abuse. So again, it's just one of those things that If we're thinking creatively, thinking cleverly, we can abuse or use HTML5 against web applications. But remember, this is the scenario that needed that cross-site scripting vuln in the first place, and that's what the fundamental problem is. One of the other things, though, I thought was a little bit more interesting is that we could also abuse content security policy to forge a post method. And being able to forge a post method is actually really cool if we're trying to build CSRF attacks. And we do this because one of the cool things about CSP is it has what's called a report URI. And this was built into the spec for two reasons. One, so that you could see who's attempting to violate the directives, who's attempting to build pages and hack. But more importantly, I would say, it's a way so that you can figure out when you're decoupling that HTML and JavaScript, what pages are broken or what's not working for you. So it's basically a debugging method. But we could build our own CSRF attack that actually has a report URI of those CSRF payload, basically. And what happens is we get a post method, which is pretty cool. We have our payload, so some page, and an origin header is present, which is interesting. The only catch is it's not a perfect attack because the post body is set in stone by the browser. So in blue here, we can affect the value of the document URL and the value of the violated directive, but we can't do anything as cleverly as add some extra ampersands and name value pairs. So it's only a partial CSRF attack, but it's a way that we should be looking at these HTML5 specs, and we need to be poking and prodding them so that we make sure that the spec says something like the origin header should be present so that web applications can now look for this and verify where it's coming from, as well as making sure that the values here are being URL encoded properly to defeat these types of attacks. There's cross-site or cross-origin request sharing. I'll mention this only because it's a way of basically weakening the same origin policy. So as much as we were trying to say we should have more granular access, there's plenty of legitimate websites, web applications that want mashups, basically, which even though the word mashup is probably lost popularity, the same types of web applications that are doing so are adding them. And these are just some points about that. And I think the biggest point about this is what I want to say is that cross-origin request sharing, aside from being a difficult thing to get out of my mouth today, is it's a definition of trust, not security, meaning that you're trusting this origin to be able to read your content. And that also can mean you're trusting this origin to abuse, misuse, or have vulnerabilities that you're now sharing. So you could also call it cross-origin vulnerability sharing if you wanted to. It's a measure of trust, not security. And so if we take a little bit of a shift here, checking time, there's some interesting things that are also with HTML5 are going to happen on the server. So I did mention, for example, the origin header. The origin header is a new header. It's basically a stronger version of a referrer. It basically means that this origin was the source of the request. So now we could look at something like perhaps a CSRF attack and see where that CSRF came from something.ru or .cn or your favorite APT of choice, and rather than coming from eBay.com, PayPal, Google, Gmail, and so on. But it's something that needs to be verified. What I've found interesting with things like server-side with WebSockets and Node.js is these are new technologies and actually new protocols. So WebSockets is actually really interesting because finally we have something to talk about just beyond HTTP. And with WebSockets and Node actually running JavaScript on the server, we want to avoid falling into the trap of actually re-implementing the web server itself. Because if we re-implement the web server, we're going to see, once again, we have directory traversal vulnerabilities. We have content vulnerabilities. We were able to fingerprint the types of server rather than just doing something like WebSockets should hook up to a VNC or hook up to an audio. We don't want to re-implement Apache and Nginx inside Node.js. I think there was a question? No, so the question is, so the origin header will be present on all modern browsers, but only in specific circumstances. The catch is that referrer, for example, wouldn't necessarily show up from an HTTP to HTTPS transition. It may also be stripped by proxies for privacy reasons. Those same proxies might also strip origin because they're either ignorant of it or they want to strip it for some reason. So again, we have a problem, or we as the security community have a problem that we want to build better browsers and better SSL and require TLS 1.3. However, we have 20 years of web applications and websites and content that still needs to show up in that browser. So for all of you that wanted to go back and look at old GeoCities and blinking HTML, most of your browsers will support that except for the blinking part, which is nice because that was annoying. The point I wanted to make here, as I was talking about server-side implementations, is that should give a shout out to Beef. It's basically, Beef is a good example of why HTML5 is more dangerous from an exploitation perspective. In other words, it doesn't introduce new vulnerabilities, it's just a new, great, more powerful way of exploiting the browser. But one of the things that's interesting is that Beef relies on Ruby, favorite, very secure, server-side programming or programming language. But you could actually DOS or a Beef server just by sending a JSON packet or what was expecting a JSON packet of a dot. And so this just showed, and I wanted to highlight this, not to pick on Beef, because Beef is pretty cool, nor to pick on Ruby, because all languages have their problems, but because it's new technology, new implementations, it's going to be a little bit more crusty. It's going to have a little bit more implementation problems. It's not going to have that solid years of development like Nginx and Apache have. So these are interesting things to be looking for from a DOS perspective. And we can just go back to blind fuzzing rather than dealing with more targeted fuzzing that we're doing today, perhaps. So I could probably spend all day just talking about what that list of new HTML5 features are. Wanted to highlight some additional ones of them, or what we should be concerned about, or what we should be looking at from a security and privacy perspective. And one of the things I haven't really mentioned up to this point is privacy. But for as much as we have an app patch and a geolocation and web storage and WebGL and WebPerf APIs to enable that banana bread first-person shooter, or to be able to enable offline web applications, or being able more powerful location or geolocation, all of this can also be misused against privacy. And so now browser vendors and spec developers are in an interesting balance between trading off what should go into the browser, what should be exposed versus what shouldn't. And to some degree, none of these, something like geolocation decidedly is new within a browser, but web storage, in a way, is just a more glorified cookie. And we always had the Flash LSO, the local storage objects, that had just the same privacy and ever cookie kind of tracking as something like web storage or app cache could use. And if we think about this from a security perspective, security community, we like to make recommendations and say, this is what the default security should look like in a web browser. We're still struggling on what that means from a privacy perspective. So set aside whether you think do not track can be effective from a policy perspective, but think about what the default stance of it was. The default stance was everyone can be tracked. And there was a significant brouhaha regarding whether or not Microsoft wanted to have DNT enabled by default on IE, and someone like Google says, and spec developers even saying, no, it should be opt-in and people should meaningfully opt into this. And if we take a step back and start to think about motivations, we can talk about advertising, tracking, things like this. A more recent example is Mozilla's decision, or the pull back on their decision about accepting cookies that were not first-party cookies. So once again, we have things that admittedly can also break how the web is built, how the web is put together, what expectations are. But we also have a big push and pull between what browser vendors want to do and what big website vendors want to do in order to provide us with good web applications, as well as, from their perspectives, will be good types of advertising. A few more notes on this. One of the things I think is that HTML5 doesn't necessarily make us less private. It doesn't really have an impact on our privacy from a design perspective as much as it does from an implementation. This means we really have to say it's the web browser, or the web servers, the web apps, how they're collecting data and what they're doing with that data. That's what's kind of the big problem is. One of the things that we can try and do with the browser vendors and browser developers is minimize the things that we don't really want to expose, or try to minimize how much we're exposing by default. You should, if you haven't seen it before, look at the EFF's panopticlick effort. It's a very interesting effort that basically says, I'm going to run a little bit of JavaScript, maybe some Flash if it's supported within your browser, and I'm just going to see how unique you are. The idea of how much can I fingerprint that this is you as a browser and I don't have to rely on a cookie. As much as they try to fingerprint this is a laptop, or this is a phone, or this is an iOS device versus an Android device, or this is Mozilla versus Opera, and so on. We're always going to have things like inference-based attacks. If you remember, probably back, I think, in the 2005, 2006 timeframe, there's a lot of really interesting new things being demonstrated about cross-site scripting and how to use cross-site scripting to scan, or basically exploits, how to use HTML to scan an intranet, or how to look at the color of links to figure out somebody's history. So we've always had these types of attacks well before HTML5 came along. Things like the WebPerf API may make these a little bit easier, or WebGL may make these a little bit easier from an attacker's perspective, or they just make the attack more complex, but it's basically a new manifestation of an old problem. The same thing with like the app cache iMessage and web storage. I think one of the things I want to mention here about data exposure is that we're always at the mercy of developers. And it's anytime if I'm going to use the words advanced persistent, I'm always going to follow it by the word ignorance. So advanced persistent ignorance is the reason we have SQL injection. We've had stored procedures, prepared statements for almost a decade now, at least 7 or 8 years. We can get rid of it by design. However, last several years, 2013, 2012, 2011, we can keep going back and back and back. We have web applications that are vulnerable to SQL injection, meaning that developers are making mistakes. I was giving a similar talk to this about a year ago, and I mentioned just as a thought experiment, imagine now that we have the web storage API, and rather than having the remember me password ability or the password reset function, the developer is just going to put the plain text password into the web storage in the browser. And then all they have to do is pop it up for the user. Well, there was a gentleman that came back that approached me after the talk and said that he'd actually come across during a pen test an application that had done exactly that. Someone had stored the plain text password inside the browser's database. Clearly, this is a no-no, something we would never do, but it's the idea that developers are out there, and if they don't know, or if they make mistakes, they're going to misuse HTML5 and make us more, or make us less secure because of their mistakes, not because of the spec. So, have to start to wind down now. And so what I want to do is actually, if JavaScript was harmless or not harmless at all, hopefully HTML5 is making JavaScript mostly harmless. Rather than worrying about how we're writing it or what we're doing, and should this be a for loop, or should we be doing a lookup or a property access? How should this be an anonymous function scoped? What we want to do is just say, hey, I have an iframe sandbox, or I have content security policy, rather than trying to rely on something like Facebook's FBJS type of JavaScript sandbox in a JavaScript, or Google's old CAJA effort that was basically to try to build a JavaScript sandbox for JavaScript. So we're relying on better now standards and better design to do this. And one of the things that's going to happen is that JavaScript is going to improve anyway. So on the one hand, libraries like jQuery are already trying to build themselves to be out of the box, compatible with content security policy, making it a lot easier for you to adopt and start implementing these new features. We're also, if we're going back to that brief discussion I made about JavaScript and crypto, we're starting to get a little bit closer to a trusted environment. Things like freezing and sealing an object. Jeremiah Grossman famously demonstrated a Gmail hack that relied on overloading the default definition of an array with JavaScript. That's no longer possible, partially because we as a security community have been poking and prodding and looking at how JavaScript can be abused and misused, and starting to come up with recommendations like these. And something like toStatic HTML, that's an IE only function, but it's a very good step towards basically a whitelist approach that says, this is how I'm going to prevent cross-site scripting or DOM-based cross-site scripting because I'm going to give the developer an easy way to write this out, rather than relying on patterns and regexes and guesses and whatnot. Of course, as I mentioned, mistakes are always going to happen. One of the biggest things is probably going to be around that origin header that may or may not be present. If you have done a lot of pen testing, you may have come across the x-forwarded-for header. This is basically inserted by proxies, and it gives the IP address of the client that the proxy is forwarding for. And there have been many infamous, I should say, situations where web applications relying on the IP address of the x-forwarded-for header as an access control mechanism. And now if you just open up burp or zattack proxy, insert your own x-forwarded-for header, you could bypass their access control. You say x-forwarded-for localhost or a 10-dot address, and you can bypass it. So my point here is that we should know the origin is spoofable, and that's perfectly fine. The idea of the origin header is that it's going to be present from legitimate requests coming from a legitimate uncompromised web browser, something that's just trying to be manipulated or abused via plain HTML, which is exactly what clickjacking or CSRF types of attacks are going to rely on. And just again, please, please, please just avoid that string concatenation. We have the idea of one of the concept I'm trying to focus on here, or trying to convey, is that we want to have security by design rather than just implementation. So we're still struggling with CSRF and how to have a design against CSRF that everyone can adopt and everyone can deploy easily and securely. There are still obviously good ways to do this, relying on nonces, relying on correctly double submitting cookies, concepts like this. But there's not something like a header that we can just apply that's similar to CSP. When we get to that point, then we'll finally get rid of a whole class of vulnerabilities, just like we should have gotten rid of a whole class of SQL injection with those prepared statements, or we should have gotten rid of the whole class of clickjacking just by using that extreme options header. And of course, we're getting closer to having better design to get rid of the class of cross-site scripting with something like CSP, or being able to deal with mashups and mixed origin content, and even things like sniffing. So we're getting better there as the specs improve. So there are a few things that we wanted to discourage. One, for example, WebSockets has gone through several iterations, and you can still download WebSockets and deploy a WebSocket server that supports an old legacy version of the protocol. This is a bad idea. We should only be dealing with, I think the current protocol is number 13. That should be the version and only version that we're supporting. So it's fine to be able to play with this, but one of the drawbacks we could say on the road to making that, turning the draft HTML5 into the standard HTML5, is that there were a lot of differences and a lot of quirks that happen along the way that we need to make sure we pull out of that server-side code and we ignore. Because we want to make sure we don't reintroduce quirks in thinking that the header is lowercase in this version of a browser, but uppercase in this version, or so on. Of course, avoiding storing personal data in the browser, and we want to avoid more plugins. And I mentioned this because there's some additional interesting efforts being made by, for example, Google is, I wouldn't say pushing, but has introduced or has working on something like Dart. And it's basically VB script that's secure and more efficient. But by the same token, it's still VB script. And my point there is to say that we already have a JavaScript that has its own issues, has its problems, and if we start to introduce something like Dart, a new client-side language, we risk coming back to this browser, or this site only works in Chrome, or only works in Opera, doesn't work in Mozilla, IE, and so on. The same thing with something like Knackle. It's a client-side, it's basically Flash that's more secure, but it's still a plugin that would be specific to Chrome, for example, rather than an HTML5 standard that would be in all of the browsers. So I would say, on the one hand, that's probably a good thing from a research. How do we want to bring something and adopt what we learn from that into something like JavaScript? So for example, even if you're developing JavaScript, one of the things to do would be, do you want to decide on developing natively in JavaScript or developing in Java that compiles down to JavaScript, like a closure? If you do that, if you work in like a Java to JavaScript environment, you can't necessarily work as easily with third-party libraries or see them in the same IDE. Where if you use something like TypeScript, that's interesting because you can have JavaScript code that's annotated with TypeScript, that lives in the same IDE, the same debugging mechanisms as any other third-party JavaScript. So these are kind of how do you want your developers to go forward? What is your engineering philosophy behind that? And what we want to do is start to encourage other trends. So Java continues to plague us. Java is always around, but more interestingly, we can now compartmentalize and say Java can execute on this domain or execute from this origin. We could even, if we wanted to, thought experiment, decide maybe we wanted to take like a concept like ghostery or a concept like adding these per domain or per origin restrictions and apply them to geolocation, web storage API, the gamepad API, any things that are being new and developed. On the one hand, we would start to break the web in the sense of web applications should just expect that this feature exists because it's part of HTML5. But if we want to build something that's more of a privacy browser, or we want to build things that are more secure, we could possibly think about, do we really want to compartmentalize this? Or how do we want to allow or disallow access to like geolocation? Things like this. And it's good to see that same origin policy can be more granular, and we're basically getting better security by design. So to wrap up, basically a cycle. So we can party like it's 1999, but let's not code like it's 1999. Let's adopt HTML5. Let's take advantage of these things. And HTML5 makes you more secure if your client's browser is using it and you're using it. Just saying we have an HTML5 app doesn't mean you're less secure. It means you have a more powerful app. It means you have more data that's exposed to you, so you have to be reliable about protecting the data, the security of that data, both in the browser and on your server side, but you can do more things with it. And of course, the problem is going to be that Internet Explorer 6. So if we go back and talk about something like the Aurora attacks, if I remember correctly, one of the reasons that Google talked about how they were attacked or how they became vulnerable to it was that they were relying on IE6 for a few of their web applications. So even a modern day very security conscious company still had to have that crutch of a very, very old browser. So let's actually bring these browsers up. Let's keep them patched. And if we keep them patched, we're already going to start off secure. We can start to have things like CSP, these origin headers, and have a lot of help. So thank you for your time, and that's all I've got. So I think if I didn't go too fast or too long, I think we have a little bit of time left for questions. I also will note, if you come to the Qualys booth, are giving away by now a short stack. We've run out of them, copies of my book, and I can tell you how the book hacked Amazon. Fun little story. Are there any questions right now? No hands? Cover. Right here. Yeah. Yeah, absolutely. And I think that, to kind of piggyback on the comment is basically get your input validation straight. And what I would say is if you're using a regular expression as input validation for HTML, you're probably doing it wrong and you're going to get hacked because there's a lot of ways if you're relying on it for blacklisting. If you're whitelisting, you're possibly in a little bit better situation because you're matching what you want rather than trying to figure out what shouldn't arrive. But input validation surely is the big deal. And that goes, actually, we could also say that goes for not just HTML5 apps, but for mobile apps that are downloaded from an app store but are still using HTTP as the transport mechanism. Just because it's going over HTTP and it's coming from a compiled app that's in Objective-C or it's in Dalvik or it's in Smalley or what have you, if you're not doing that client or that server side input validation, it doesn't really matter if that's HTTP. Yeah, absolutely. Actually, and again, one of the things that I found, I was just trying to do some simple security on, investigation on some native web apps. So I set up a proxy and was trying to use things like a Twitter and some other Facebook and some other these through a proxy. And what's good is that the Twitter app, the Facebook app, for example, would refuse to make the connection because the SSL certificate was invalid. So the app itself was making sure that not only is it using SSL, but it's actually using SSL for its intended purpose. In other words, identifying and authenticating that remote server. It's actually talking to Twitter. However, you could go back to a list of several different, half dozen different open source examples of how to interface with Twitter's API. And those apps, none of them were actually doing any client validation. So suddenly, you have a server. Twitter's pretty smart. Facebook's pretty smart. They know how to implement SSL. But your third-party developers, they weren't validating that cert. And suddenly, now you can very easily do those interception attacks, intermediation attacks against the devices. And I want to say there was a very good paper that was released within the last 6 or so months, something like the most dangerous code in the world, that was basically on this point, pointing out how many how many client-side applications had used tools like curl or other SSL connectors and had never bothered to validate that SSL cert. So it's the idea that we have browsers that I was kind of talking about, Mozilla, Chrome, Opera, Safari, all these that are, we can say, rather secure, but we're also starting to get mini browsers or kind of pseudo browsers inside these native apps, these mobile apps, and that's where we're going to see what's real interesting. Do they actually implement same origin policy correctly? How are they implementing things like the iframe sandbox if they're trying to use it? Are you even paying attention to those SSL certs? And that's my long rant for your question. Thank you. Question in the back.
This might be really ignorant. I'd like my website to be fully bodied with apples.
So the question is, can a site be like ADA compliant, or can it be secure for people with disabilities? My short answer is going to say yes, because that site doesn't have to be any different than any other. And not being an expert, but I'll say most of that is an implementation in the client in terms of presentation of the text, the content. Can be annotated with Ruby script, can be annotated with audio, finding things like this. So the security doesn't really come from the client, except in terms of, are you storing data, like are you storing that plain text password in the web storage API? Security is going to come from how you're dealing with with data coming to and from the server. So that's an inexpert answer, but the short answer is really going to be yes. I think we have maybe a minute left. Any more questions? Yeah. Right, so the easy step you can reproduce, install any app, set your, I have an iPhone, so set the proxy to point to like Z-attack proxy or something, and just do the traffic normally through that, and you'll be able to see, does that app reject, if it rejects it then, and it's going over SSL, then very likely it's rejecting it because it's actually verifying the cert. If you just start to see the traffic and you can interact with the traffic like you could with a normal browser, any other web application, then it's pretty much guaranteed it's not validating the cert, nor, also importantly, do you get any type of indicator that says, hey, you're trying to connect to foo.bar, or the cert is invalid or anything like that, or even the cert is expired. You don't get those. The point is, right. The point is that you don't even have to get to the point of SSL strip or anything too complex like that. You just need to be able to say, if you're trying to set up an attack, basically a DNS spoof, point them to your web server and give up whatever cert you want, and the app knows no difference because it didn't validate it. Yeah, so the idea, the countermeasures are very simple. It's, in something like, in curl, if you use like libcurl, there's verify peer, I think, or verify host, and you set it a Boolean. and or set the value properly, and you're done. It's that simple. And I got the most awesome hint from, rather than the 20-minute, 10-minute, 5-minute mark, I got the STFU hint. So it's time for me to get off the stage and let the next person come up. I thank you again. I'll be answering questions later. Thanks.